Hey everyone! My name is Emily Schultz, and today I'll be demonstrating a delicious way to measure the wavelength of a microwave using mini marshmallows. Waves are all around us in many different forms. Sound waves hit our eardrums so that we can hear, light waves hit our retinas so that we can see, and of course, microwaves from a microwave oven heat up our food. To find a wavelength of a microwave, we must first understand frequency and speed. The frequency of a wave is given by how many waves pass a certain point in a certain amount of time, often measured in hertz or megahertz. The frequency of a standard microwave is 2,450 megahertz. The speed of any wave on the electromagnetic spectrum is 3 times 10 to the 8th meters per second, otherwise known as the speed of light. Given the frequency and speed of a microwave, we can then predict the wavelength using the equation speed over frequency in hertz equals wavelength. So 3 times 10 to the 8th over 2.45 times 10 to the 9th equals 1.22 meters, which divided by 100 is 12.2 centimeters. Using the microwave, we can confirm the wavelength that we calculated. This lab is completely safe to do at home with your own microwave. You will need paper plates, mini marshmallows, and for an extra fun twist, graham crackers and chocolate. First, you have to take the spinning plate out so that the marshmallow plate doesn't spin. The setup I used included a bowl flipped upside down as well so that the marshmallows would be in the center of the microwave. The paper plate on top is simply for more balance. Take some mini marshmallows and line them up on your paper plate in as straight of a line as you can manage. Eating some is completely acceptable too. Place them in the microwave and set the time for a minute. As they microwave, you'll see certain marshmallows begin to move and puff up and cook, but not all of them. Keep your eye on them though, because they'll burn if you don't take them out soon enough. When they look nice and puffy, take them out and let them cool slightly. At this point, you can see clearly that only certain marshmallows were being cooked. The others might be warm, but the puffed marshmallows were being hit by the wave directly. On the plate, you can graph a wave and see that the crests and troughs fall where the marshmallows were being cooked. This way you can measure the wavelength. During my trial, the wavelength I measured was 8.5 centimeters, which is far off from the calculated value. However, every microwave is different, and this lab is not meant to be a replacement for professional experimentation by actual physicists. It is simply a way to experience visual evidence that waves are always at work. From the sunlight we bask in to the music we listen to, and even the way our minds function, waves are constantly around us in the form of light, sound, electrical signals, and more. Although we cannot see the waves around us oscillating, this lab is visual evidence that all of the waves around us exist and have unique frequencies, speeds, and wavelengths that are important to understand. For most people, seeing is believing, but I think eating a good s'more after a day of science is believing too. Thank you for watching.